try to solve Leetcode problem 583, delete operation for two strings. So for this problem, we are giving two strings word 1 and word 2. So we're gonna return the minimum number of steps required to make word 1 and word 2 the same. So in one step, you can delete exactly one character in either string. So what we're gonna do for both of the strings, we just need to do the delete operations. So let's just use the first example. So for word 1, SAE, and for word 2, EAT, and we just need to delete the first character S in word 1 and the last character T in word 2, and then this EA and this EA, it's gonna become common. Yeah, it's gonna become it's gonna become the same, EA and EA. We just need to check how many operations, so it's gonna be 2 operations. Yeah. So for such kind of problem, actually, it is we need to translate this problem into a longest common subsequence problem, and then we're gonna solve it easily. So what is the longest common subsequence? It's gonna be EA and EA. So what's gonna be length of the word 1? It is 3. Length of the word 2? It is 3. So 3 plus 3, 6, minus the longest common subsequence. It's gonna be 2 times 2. So the final result gonna be on 2. Yeah. So if we know how to calculate the longest, what's gonna be the longest common subsequence, it's gonna be easily. Yeah, but what if you don't? If you don't know how to calculate it? So basically, we're gonna use the dynamic programming idea. So let me just go back a little bit. Yeah, so we have the characters SEA and EAT. So what we're gonna do is that we're gonna compare with the last character, or you can compare with the first character. It doesn't matter. Yeah. So for example, if we're gonna compare with the last character, this A and this T, if they are not equal, so what are we gonna do? If they are not equal, so for example, this is S and this is the string T, this is the string S. If they are not equal, we're gonna check the subsequence. So we're gonna check SEA with EA. Another one is gonna be SE with EAT. Yeah, we're gonna check the maximum of the two result. So now we let the problem become a subproblem. This is for the situation if this character A is not equal to this character T. If they're not equal, we're gonna do such kind of operations. So now we're gonna solve the subproblem. So now for this one, this A, they are equal. So if this A equal to this A, so we're gonna still to solve the subproblem. It's gonna be as E and E. So we're gonna plus 1. This means this A equal to this E. So it means the length gonna increase by 1. Yeah. And then we're gonna continue. This E gonna equal to this E. It's gonna become 2, and it's gonna come to here. This is string S, and empty string. So this character S compared with empty string, so definitely it's gonna be 0 because they are not common. Yeah, they are not equal. So the final answer is going to be 2. So this is the basic idea. Now let's just use DRBS with memorization to solve the problem. So I'm going to prepare 2 indices I and j. And finally I'm going to return f with r minus 1 and c minus 1. R and c going to be length of the word 1 and word 2. Yeah, let me just finish writing here. Yeah, now what are we gonna do? We're gonna check the index I and j. If I is less than 0 or j is less than 0, basically it means it's not possible, so we're gonna prepare the edge case. It's gonna be a 0. Yeah, but what if word 1 I equal to word 2 j? So if they are equal, we're gonna use the first situation. It's gonna be yeah. So if they are equal, we're gonna directly check the subproblem. Yeah. So we're gonna have a return of the subproblem. It's gonna be I minus 1 and Z minus 1. So this is the subproblem, but we need to plus 1 because we increased the length by 1. Otherwise, if they're not equal, so we're gonna return the maximum of the two subproblems of I minus 1 and J, and I and J minus 1. Yeah. Now let me just submit it and to check if it works. Just run it. As you can see, it didn't work because now we are calculating the longest common subsequence, LCS. It is 2. This means it is okay, this EA. And for the second one, it is something like ETCO, it's going to be 4. Yeah. Now we just need to finish the final calculation. It's going to be this one, R plus C minus the result times 2. So this is going to be R plus C. Yeah, so the length of the two streets minus yeah, there's still something wrong. Let me think about it. Yeah, let me just go back to check why it is wrong. So my result is 3. It should not be 3. It should be 2. Yeah. Yeah, I hope everything should be okay, but let me just check. This is for they are equal. This is for they are not equal. Yeah, I think it's going to be 2, but I did something wrong. Let me just go back and check my previous coding, why it is wrong. I don't know. Yeah, so this is my coding. Yeah, so I still don't know why. Let me just check the code I submitted before. It should be a really easy problem, but I don't know. Sometimes I cannot find the problem why I did it wrong. So this is the max. R plus 1, R plus C minus this one times 2. Yeah, I did it wrong. I don't know why. Yeah, let me check the code line by line. Which one is wrong? So I think here it's exactly the same. Yeah, the same. This line, and here I return a 0. It's the same. Yeah, here I did something wrong. I don't know. Sometimes I did the typo problem. This is word 1I equals to word 2j. Yeah. And now let me just submit it. And now as you can see it works, and now let me just submit it. Yeah, as you can see it passed for all testing cases. Yeah, so the idea is that this is a longest common subsequence problem. And we just need to find the longest common subsequence, and then just use some basic mathematical formulas to find the delete operations for the two string. I think that's all about it. Thanks for watching. See you next time.